So today we're doing day 2 of solving systems by substitution. So we're going to still solve systems of equations by substitution. We've already done it once. So have out your packet, and if we get a chance during class, you'll see the first couple of slides will be if I'm in class. We're going to go over those again. But otherwise, have your workbook open to page 80, and of course be ready with a calculator and a pencil. So the first three slides are actually going over any questions, but since I'm not in a room with you, I can't answer your questions right now. Hopefully you've checked your answers. So we're going to just start off by using substitution. And remember, with substitution, what we want to do is we want to get a variable by itself. And so we already have x by itself, so we're going to take this and plug it in for x. So in place of x, we're going to put y plus 6. Everything else stays the same. So we just replaced x with y plus 6. Now we have one variable, y, and we can just solve the equation. So now we're just going to go through and solve. We combine like terms, 2y plus 6. We're going to solve this equation, and we get y equals 2. We need to always remember that when we have a system of equations that we're always going to have two variables, an x and a y. So once we have the one variable, we plug it back in, and it doesn't matter which equation we plug it into. I'm usually going to plug it into the one where it already has a variable solved. So x is equal to 2 plus 6. So we get x is equal to 8. So our answer is 8, 2. Now I also want to refresh your memory on how we check this. If I want to check and see if it's right, I have to plug this answer into both of them, and it has to be true for both in order for it to work. So if I plug in into the first one, 2 is equal to 8 plus 6. Do you see my mistake? I put the wrong x and y in there. Silly me. So 2 is my x is my y, and my x is 8. There we go. And that does give me 8 equals 8. Now I'm going to plug it into the second equation. 8 plus 2 equals 10. 8 plus 2 is 10, so yes, that one works too. So we've just checked it. So we plug it into both equations, and we see that it has to be true for both. Good. So I'd like you to try the second one. I'd like you to turn off yours right now and go ahead and try it on your own. And I, of course, will be doing it here, and I'll stop and turn it on at different parts. But please try this one on your own. Pause yours and try it on your own. These are in your book on page 80, so you can just be doing them right in your book. So you can see that I just substituted in. I took 2x minus 1, and I plugged it in for y. And I did it in purple so you can see it. So now you're going to solve that equation. Go. And I have that x is equal to negative 1/2. Now I'm not finished. I have to now go find y. So I'm going to plug it into that top equation, just because it's kind of already set up for us. So y is equal to 2 times x. And again, my x I just solved for, minus 1. And then I just simplify that. So that's going to give me negative 1 minus 1, negative 2. So my answer is negative 1/2, negative 2. Okay, and hopefully you got that also. So the next problem in your book is probably one of the biggest reasons that we actually do systems of equations is word problems. If you're like me, word problems are not your favorite, but they're going to be now because they are so much easier. So let's read the problem, and I'll highlight things that you need to pay attention to. On Saturday, the vacation resort offers a discount on water sports. To take a surfing lesson or go parasailing costs $130. That day, 25 people take surfing lessons, 30 people go parasailing. A total of $3,650 is collected. What is the discounted price for each activity? Okay, so first off, what two things are we talking about? We're talking about a surfing lesson, and we're talking about a parasailing. Okay, now it says to take a surfing lesson and go parasailing costs $130. Well, that's the beauty of a system. I just call each of them a letter. I'm going to call this one P, and surfing lesson, I'm not going to use S, so we're going to just use L for lesson. So we know that L plus P is equal to $130 because that's what it says it costs. Then it says 25 people take the surfing lessons, and 30 people go parasailing. And there was a total of $3,650. Okay? And that's all you have to do to set it up. Now we're just going to solve it. So we have to get one variable by itself so it can substitute into the other. You're going to probably either choose L or P. It doesn't matter which one you choose. I'm going to choose L just because it's right there. So I'm going to move the P. So I'm going to subtract P from both sides so I can get L by itself. So I'm going to get L is equal to 130 minus P. And I'm just going to take that and plug it in place of L. Okay, so I have 25, and I'm plugging in 130 minus P. Now I just write down the rest of the equation. And we're going to solve this equation. Okay, so we're going to solve this equation. Go. Pause yours, solve this equation, go. So when you solve this equation, you came up with P equaling 80. Whoops. And if you didn't, pause your screen right now, go over it, and see where it is. So what that means is that there were 80 that went parasailing. And now I'm going to plug that in to get how many took lessons. So I'm going to take 130 minus 80. That's, of course, 50. So I had 50 that took surfing lessons. But you see, the hard part about word problems is setting up the equations. Well, now that we get to have two variables, it's a piece of cake. So just wanted to see that. We'll keep practicing word problems, but they'll actually be almost fun because they're not so difficult now. Okay, so this is just the habits of mind in your book, and it's always good to think through these. If you visit the vacation resort and find the cost of surfing lessons and parasailing by graphing the system of equations, what will you need to remember about the solution that you find? Well, one, if we were really going to do it, we need to know that it has to be whole numbers, and to graph this would be a pretty big graph. If you're going to graph it, make sure you have a graphing calculator or you're using Desmos. But you can see it would be a real pain to actually hand graph that if you look at those equations. So just want your mind to think through that, keep that in mind, and also keep in mind you're talking about people as far as taking surfing lessons and parasailing, so that means it would have to be a whole number. The next thing you encounter in your workbook are the try it problems 3A and B, and so we're just going to try these and plug them in. So we're going to, of course, take one and plug it into the other. So I'm going to plug this in for y. So I have x plus negative x plus 5 because I'm plugging that in for y. I put it in parentheses just to kind of help me see that's what I'm actually plugging in. I now have two variables, so I'm going to continue and solve. I combine like terms. Oh, okay, there we go. Look, x and negative x, those eliminate. So they add to 0. So I get 5 equals negative 4. Does 5 equal negative 4? No, it does not. And whenever it doesn't equal, we know this is no solution. Now think about that for a second. If I have a system of equations, I have two lines. If I were to graph these, what would they look like? That's right, these are parallel lines. So if I were to graph these would be parallel lines, and you can see that. If you rewrite that first equation, you're going to get y is equal to negative x minus 4. So see how your slope is the same? It's a negative 1 in both. So you're going to have parallel lines right there. Okay, good. Let's look at the second one. Again, we're going to substitute in for y, so that's not a big deal. We're just going to do that problem now and substitute in. So we have 2x plus, but in place of y, we're going to plug in what y is equal to. And here, y is equal to negative 2x plus 5. Aha, and there we go again. Look what happens. You go to combine like terms, they eliminate, but we get 5 equals 5. So what you need to understand is this is a true statement, so it's many solutions. It is not all solutions. You cannot say all real numbers, because think of the graph of this. If I graph this, it's the same line. So it's many solutions, infinitely many solutions, but it's not all real numbers because it is only where the line is. So my graph, remember, if I were to look at this as far as a graph, these would be the same line, and it'd be something like this if I'm just drawing a generic, but it'd be everything on that line. This point over here is not part of a solution, so we cannot say all real solutions. Oops, let's spell graph right. Good. Yay, we get to know another word problem. And again, why would you ever say yay with word problems? Because we're in systems. And with systems, wow, it is awesome to do word problems. So let's read through it once, then we'll go back. Funtime Amusement Park charges $12.50 for admission and then 75 cents per ride. River's Edge charges $18.50 for admission and then 50 cents per ride. For what number of rides is the cost the same at both parks? So, the only mistake I made is that I thought it was going to be A and R, but what it's going to actually be is that you're going to talk about the total cost. Okay, so the total cost, oops, total cost, okay, is going to be Y, and your R is going to be your X. So we have Y equals 1250 plus 75 R for number of rides. And then we have River's Edge, which is going to be Y equals 1850 plus 50 cents per ride. Okay, those are R's. Now, that's going to be Y is your total cost, so I could have used T. So it's the total cost for Funtime and the total cost for River's Edge. Now, notice they're both equal to a Y. So all we have to do is find out when they're going to cost the same. So same, meaning when are they equal? So we're just going to take and set those equal to each other. 1250 plus 75 cents R is equal to 1850 plus 50 cents per ride. So we're going to find out how many rides is going to be the same. Okay, let's solve this equation. Okay, so let's combine like terms. Let's decide which one we're going to move. I'm going to move the 50 cents, just so then when you come back you can see. So I'm going to subtract 50 cents from both sides. That's where I'm going to start. Okay, ready, go. Okay, so we came up with R being equal to 24. So what does that mean? For what number of rides is the cost the same? 24 rides. It would be the same price. Okay, good. So the next one is another word problem, and it says Healthy Start Gym charges $32 for membership and $6 per cycling class. Fast Fitness charges $25 for membership and $6 per cycling class. Does a number of cycling classes exist for which the cost is the same at both gyms? So this is very similar to the last problem we did. I'd like you to try to set up those equations. Go. Pause yours and do it. Okay, so hopefully you wrote down Healthy Start. Oops. So for Healthy Start, you're going to have a total cost. Okay, Y is equal to 32 plus 6 per cycling class. So we're going to call that X, and Y is our total cost. And then for Fast Fitness, we're going to have Y is equal to 29 plus 6 per cycling class. Now we just set them equal. So on this one, we are going to talk about Healthy Start Gym and Fast Fitness. So let's read the problem first. Healthy Start Gym charges $32 for membership and then $6 per cycling class. Fast Fitness charges $29 for membership and $6 for cycling class. Does a number of cycling classes exist for which the cost is the same at both gyms? Well, when you look at this, okay, so one is 32, one is 29, but they're both $6 per each class. So there's not a number, and so let's look at the equation. If we have Healthy Start, it would be 32, so Y equals 32 plus 6X. And Fast Fitness would be Y equals 29 plus 6X. So if I write this equation, because we would just set them equal, notice what's going to happen. We're going to get no solution, because C would subtract 6X, and we get 32 is equal to 29. So there is no way, but you would have figured that out anyway, because look, it's $6 per cycling class. So he would have gone, well, they're the same, so it doesn't matter. Does the number of cycling class exist for which the cost is the same? No. One is always going to be more because the membership is more. Okay, good. So now let's go through these just to make sure we're all on the same page. How to use substitution to solve a system of equations. To solve a system of equations, You want to first, and this is what notes you took on the very first day from the old video that we used, is you always want to get a variable by itself. Get variable by itself in one of the equations and substitute it into the other equation, okay? But you have to get a variable by itself, plug it in the other one, solve for that variable, go back and get the second one. And again, refer to the videos from the first day of lesson 4.2 if you have more questions about that. Number 2, use appropriate tools. When using a graph to solve a system of equations, when is using a graph to solve a system of equations more useful than substitution? So this was the big clue, the tools. If I have a graphing calculator, or if I want to use Desmos, then it's more convenient to graph. Usually it's more convenient to use substitution or the next method we'll use that is called elimination. But if you have a graphing calculator, that'd be awesome and you could use that. Number 3, Simon solves the systems of equations in x and y. By substitution, gets an answer of 5 equals 5. So 5 equals 5. So we know, okay, it's going to be many solutions. He states that the solution is all the points where x and y are real numbers. And we've described this before. We've talked about this before. The error is it's many solutions and it's only real numbers on the line, okay? So he's saying that it's all real numbers and it's not. It's only many solutions, and it's only many solutions that are on the line. Now we can just write many solutions, but it's because they're on the same line. So it's not all real numbers. Not all real numbers. They have to be on that same line. Okay? Good. And number 4, I actually put up the correct answer because I wanted you to see. Okay, so let's read the problem. When solving a system of equations using substitution, how can you determine whether the system has one solution, no solutions, or infinitely many? One solution means that you're going to have a variable left. So they talk about that one right down here. You're going to have x or y being equal to a number. If it is no solutions, you're going to get a false statement. So if you have a false statement, it's no solution, you have parallel lines. If you get a true statement, C equals C, it's going to be many solutions. So it's very similar to when we were solving equations, but I just wanted to point that out. This might be something I would probably write this down in your notes just to have it to refer to. It'd be a good thing to study from, I think. Okay? So you might want to pause and do that. Now on these, what we're going to do is they gave us really nice ones. They already have a variable solved for on both of them. So I would like you to stop your screen right now, pause it, and go and do these, and then come back and compare your answers. I will do one at a time, but I'd like you to try these on your own first. So far I have x is equal to 2. Of course, we're not done. We now take that and we're going to plug it in to find y. So I'm just going to take this equation up here. Y is equal to 6 minus 2 because I'm plugging in for x, and I get 4. So my answer is 2, 4. Always write your answer as an ordered pair. Okay, let's do number 6. Go. And in solving for y, you would have gotten y is equal to 2. Now, these don't always come out to be 2. That's just weird. Now I'm going to plug that in to find x. So I'm going to go back up here. X then is equal to 2. Whoops, negative 2. Oh, hold on a second. We have to pay attention to that negative. Okay, so this is a negative of what I came up with. So it's a negative 2 plus 3. So I get 1. So my solution is 1, 2. Good. Hopefully those went well for you also. Once again, we're going to solve. So pause yours and go ahead and solve. Oh, wait a second. Look at number 7. Number 8 is nice. They already have y solved for right there. So they already have what y is equal to. But on number 7, let's pick a variable that we're going to solve for. And let's think about it strategically. So if I were going to solve for y, I could do that. But I have a negative. Eck. I avoid negatives because I mess up on those. But look at equation 2. It has an x. So I'm going to get that x all by itself and plug that into the other one. So I'm going to start by subtracting 2y from both sides. Therefore, I get x is equal to 6 minus 2y. While I'm here, let's just go ahead and solve it. So I'm going to plug that in, 4x, into the first equation. Okay, so I took what x was equal to, and I'm plugging it in for x up here. So I get negative 18 plus 6y minus y is equal to 7. So negative 18 plus 5y. You can read. So I get y is equal to 5. Now we're going to go find out what x is. So we say x is equal to 6 minus 2 times 5. we get 6 minus 10, which is negative 4. So my solution is negative 4, 5. Go ahead and do number 8 now on your own, plugging in y right here into the original equation. Go. So now remember, you don't stop right here. Even though on this line right here, you probably kind of knew what the solution was. You go until the variables are not there. So make sure you continue. So negative 6 equals negative 6 is true. So my answer is many solutions. And what does that tell us about the graph of this? If it's many solutions, that's right. This would be the same line. And that's where my solutions would be, on that same line. Okay, it's not all real numbers. It's many solutions. Good. Yay, now we're going to do the fun part. The only time, well, not the only time, but one of the rare times that word problems are fine. So here we go. Let's read the problem. A sports store sells a total of 70 soccer balls in 1 month and collects a total of $2,400. Write and solve a system of equations to determine how many of each type of soccer ball were sold. Well, yay. That kind of tells us here are 2 types of soccer balls, right? We have the limited edition, and we have the pro. So let's just give those letters, and you can always call them X and Y, but indicate what they are. So if you're going to put X and Y, put X and Y right above that. I like to kind of label them by what they are. This is the limited edition, and this is the pro one. So I'm going to call them L and P. And it sells a total of 70. This is such a typical problem. We always talk about the total number, and then we talk about the price. So if I have a total number, that means I add the 2 together, and I get my total number. Then we talk about the price. What is the total cost? Well, this one costs 65, so 65L. This one costs 15, so 15P is equal to my total of $2,400. Okay? See how easy it is? Aren't those fun? It's just cool. Okay, so now we're going to solve for a variable. Again, choose a variable. It doesn't matter which one you decide, but we're going to have to choose one. I'm going to choose to solve for L, so I'm going to subtract P. Okay? So I have my equation of L is equal to 70 minus P. I'm going to take this and plug it in for L. I'd like you to try this one on your own. Go. So now at this point you get here and you got, wait, I've got negatives. How am I going to have negative soccer balls? But notice they're both negatives. So when you divide, okay, you're going to come up with a positive of P being equal to 43. Okay, so what does that mean? P is 43. Well, P is our pro number. So we sold 43 pro NSL balls. Okay, now I'm just going to plug it in here to find the other one. 70 minus 43. And we get 27 of the limited edition. See what I mean by these are almost fun? Because the equations are easy to set up. Good. So what I did next is that I took 3 problems out of your workbook, and we're just going to do these problems. So this was out of the practice assignments. And the reason I did this is because you're going to have one similar to this. So then you will have it to refer to. So Richard and Teo have a combined age of 23. Richard is 5 years older than twice Teo's age. How old are Richard and Teo? So Teo, I'm not sure. Okay. So we have 2 people we're talking about. Guess what? Those are our variables. So how about if we go with Richard and Teo? Okay, R and T. So it says their combined ages are 23. So we're going to have Richard's age plus Teo's age is equal to 23. Each sentence is pretty much going to give us an equation. Now the second equation, what I want you to pay attention to here is it says Richard is. Remember that verb is going to be an equal sign. If we haven't talked about that enough, then we need to. When you get to a verb, that's going to be your equal sign. And a lot of times it is that linking verb of is. And also notice who was mentioned last. So it makes sense. So Richard is 5 years older than twice Tay's age. Did you see how I did that? I just went from left to right, and I read it, and I wrote, Richard is 5 years older, so 5 plus, twice, 2 times Teo's age. Yay! Isn't this awesome? So we're just going to plug those in and solve it. Go! So did you get T equals 6? Good. Now we're going to take that, so that's Teo's age. So Teo is 6 years old. Okay, now we plug it in for Richard's. 5 plus 2 times 6, 5 plus 12, and we get 17. So Richard is 17. And before we would have had to symbolize all these different ways, but because we have 2 variables, it makes it awesome. This is supposed to say years. You can't read my handwriting. Okay, good. And the problems I picked for you are fairly typical ones, and that's one of the reasons I wanted you to see how they were done, because these are ones that show up all the time when we're talking about systems of equations. So let's read it again. Susan has a collection of 75 nickels and dimes. If the number of nickels is 4 times the number of dimes, how many nickels and how many dimes does she have? So what two things are we talking about? That's right, nickels and dimes. Okay, so nickels and dimes. I'm going to use a lowercase n. So nickels and dimes. So she has a total of 75. She has a collection of that. So we have n nickels, number of nickels, and d number of nickels, and that gives us 75. See, isn't that wonderful? Okay, now here on the second one, it talks about the number of nickels is. There we go. So n is 4 times the number of dimes. Oh, well, that was easy. There we go. That's our equation. That's our system, I should say. Those are our equations. That's our system. So now we're just going to plug one into the other. Plug this in here. Ready? Go. Did we get d equals 15? Exactly. So we have 15 dimes. Now we're going to plug it in here. So the number of nickels is 4 times 15. Isn't that always the truth, that you always have more of the smaller one? Anyway, so we have 60 dimes. So we have 15, sorry, that's nickels, 15 dimes and 60 nickels. Aren't these great? And for our last one, it says a rectangle shown has a perimeter, okay, think about perimeter, of 52 centimeters and the given area. So it tells us our area. So it's going to tell us our area is here. It's going to tell us our perimeter is 32. Okay, we'll come back. Its length is 6 more than 4 times its width. Write and solve a system of equations to find the dimensions of the rectangle. Okay, so we have a lot of things we can put down. One, let's keep in mind, perimeter is where we add up all the sides. So that would be L plus W plus L plus W. Okay, so that gives us that the perimeter is equal to 2L plus 2W. Okay, so there's one thing that we know. What else do we know? We know the area. Oh, and do we know the perimeter? Yes, the perimeter is 52, so we get 52. 52 is equal to 2L plus 2W. So there's one equation. Now to get the area, how do I find area? That's right, I take L times W. So I have 88 is equal to L times W. Okay? The other equation where it says its length, okay, so L is 6 more than 4 times the width. Wow, we have equations all over the place. Look at all of our equations. Okay? And we're going to use just 2 of those in order to come up with it. And let's see which ones we want to use. Well, I'm going to use this one because I think that's an easy one. And then this is pretty short, so I might use that one. Okay, and I'm just going to substitute in. So I'm going to take this and plug it in for L. And so then we can come up with it. So we have 88 is equal to 6 plus 4W. That's what we're plugging in. And then times W. Okay, well, there's the problem. We can't use that one because you don't know how to solve that yet. You're going to get W squared. So no, we can't use that one. Okay, well, that was helpful to know. Now let's go and plug it into this one. So 52 is equal to 2 times whatever L is. And here L is 6 plus 4W plus 2W. Now this we can solve. Okay, this one we'll have to wait until a couple more sections. So let's go ahead and solve this equation right now. And we're going to come up with that. So go, solve. Okay, so you got the width was 4. So my width is 4. Wow, can't write. 4 centimeters. Let's go find the length. 6 plus 4 times 4. So we get that the length is 22 centimeters. So that problem just gave you more than we needed, but hey, that was great setting everything up, and we found our answer, and so that's what matters. Okay, so just pay attention to that. Good. And that's all we're going to do for this lesson. Hope it goes well for you also. If you have questions, you know where to find us.